In this video, we're going to look at some questions on the history of the atom and different models. Read all of the information on the left-hand side of the sheet, pause the video, and answer these questions. So, question 1A, why were so many models of the atom abandoned in favour of new models? There's one simple idea that's going to come again and again, and that is of evidence. If we find out new evidence, then we of course are going to update our ideas. So this is a good answer for 1A. Question 2 is a slightly longer question. This is a 6-mark question. So it appears quite complicated because we've got other technological advances which maybe aren't always highlighted, but it's actually quite an easy question to answer. So the key thing is a new model of the atom to be developed by Rutherford. So if you remember Rutherford's experiment and the results, you can get most of these marks really easily. So Rutherford fired alpha particles at a very thin sheet of gold foil. Most of them went straight through. Some of them were deflected, and 1 in 10,000 bounced straight back. So that led him to develop several conclusions for the atom. So he realized most of it was empty space. There was a small positive nucleus that would repel the positive alpha particles. And the final part of the question is to think about the technological advances. So really, this is just a bit of common sense. Alpha particles were discovered in the early 20th century, along with radiation. Before that was discovered, this experiment couldn't have been done. Things like detectors or the ability to make very thin gold foil that was only tens of atoms thick. Again, new technology that did not exist hundreds of years ago, so could not have been done. So I've summarized all of that for you here. Question C says, what does J.J. Thomson's model predict? So you obviously need to know what J.J. Thomson's model is. J.J. Thomson's model is the plum pudding model of the atom. So we have a positive charge that is spread out in uniform and some negative electrons that are sort of stuck on. So this predicted that the alpha particles would pass straight through because there was no overall charge to repel the alpha particles, and there was no empty space. That means there could have been some charge and then space for the alpha particles to do something different. All of this plum pudding model looked exactly the same to the alpha particles. Question D. How is Chadwick's model of the atom different from Rutherford's model? So really easy answer. Chadwick's model included a neutron, which is neutral. It does say explain your answer. So why could Rutherford not have known this? Well, positive alpha particles are repelled by positive particles, and a neutral neutron will not repel the alpha particle, so it was harder for him to tell there was something else in the atom or in the nucleus. Question E, what are the similarities between Rutherford's model and Bohr's model? So there's a couple of similarities. Both of them had a small nucleus surrounded by lots of empty space, and they both had electrons round the outside. Bohr went into more detail about them being in fixed orbits at different distances, but Rutherford did realize that they were in a circle around the outside rather than being stuck all over the atom like the plum pudding model. And then finally, question 2, what does peer review mean? So peer means friend and review means check. So it is basically that idea when other scientists check each other's work, and that's important because you can spot errors or see if they agree. And if scientists agree, there's a good chance that that science is more likely to be correct. It doesn't guarantee it, but it's more likely. B, what should a new model or theory do better? So this is the key idea. This is all about evidence. Really, really simple idea. And finally, C, scientific models and theories change with new discoveries and understanding. What does that suggest? Well, it suggests several things. 3 of them are listed here. All right, and these are slightly different, but 3 equally important ideas.